Hi everyone, I'm Jeff Krause, and today we're going to take a deeper look into the topic of active probes. The main difference between a passive probe and an active probe are that passive probes contain no active components that must be powered, while active probes contain an amplifier near the probe tip. This is most commonly based on a transistor or FET. Active probes typically offer higher overall impedance, which present high resistance to DC voltages and low frequency signals, and low capacitance to high frequency signals. Active probes have high resistance at the probe tip, but terminate into a 50 ohm input of the oscilloscope. When considering active versus passive probes, probe impedance is an important factor. Passive probes provide the highest impedance below frequencies of 20 kHz. Their high input capacitance causes circuit loading at high frequencies or low frequency signals containing high frequency content. Active probes, however, provide high impedance from DC to 20 kHz, maintaining that impedance out to higher frequencies thanks to their low input capacitance. So based on this, when does it make sense to use a passive versus active probe? Passive probes are an excellent choice for low frequency measurements, especially if high voltages may be encountered. Active probes are better suited for measurements requiring high bandwidths. And active probes are a great general purpose choice for all frequencies out to the multi-gigahertz range, but watch out for higher voltages, which could cause damage to the probe amplifier. Let's look at an example when an active probe is a clear choice over a passive probe. Here, we have a 50 MHz square wave as it looks with a direct SMA connection to the scope. On channel 2, I have a passive probe attached, and we'll attempt to probe this clock. Notice how both the probe signal and the direct connection signal are distorted due to the excessive loading. Now I will use an active probe instead on channel 2, and we'll connect it to the clock signal. This time, you will see that both the probe signal and the direct connection signal look much more like the signal we want to probe.